Hello, everyone. Thank you for joining us. My name is Alex Galassini, and I'm one of the program managers at the Chicago Council on Science and Technology. We'd like to welcome you to today's program, Every Breath You Take, Air Quality in Chicago. This program is brought to you by C2ST in partnership with the Northwestern University Department of Earth and Planetary Sciences. We'd also like to thank EPIC at the University of Chicago for helping promote this program. If you're new to C2ST, we are a not-for-profit organization that was founded in 2007 that works to enhance the public's understanding and appreciation of science and technology and their impacts on society. Please visit c2st.org to learn how you can donate and find information about our upcoming programs. You can also sign up for our mailing list so that you can get reminders about these programs. To ask questions of our expert during this program, please type c2st2.cnf.io into your browser and click on today's session. This is also where you can evaluate the session afterwards. Additionally, our staff will be checking both C2ST TV on YouTube and our Facebook live stream for your questions. Now, I'd like to introduce our speaker for today, Anastasia Montgomery, who's a PhD candidate at Northwestern University. Anastasia is a PhD candidate in the Department of Earth and Planetary Sciences, and she works in the Climate Change Research Group, where her aim is to better understand the interaction of air quality and climate change in urban environments. Anastasia uses a number of cutting-edge techniques that she's going to be highlighting for us today. Anastasia, thank you for speaking with us. We're really eager to hear about your research.
Thank you. I guess I can get right into it. I'll start sharing my slides now. All right, can we see my slides?
Yep.
Great. All right, hello everyone, and thank you for coming to my lecture. Today I will be talking to you about air quality in Chicago. So a little bit about myself. My name is Anastasia Montgomery, and I actually grew up outside of the city of Chicago, and my scientific career actually got a pretty early start. Here I am presenting on my project, Money from Around the World, a project advised by my first advisor, my father, who totally is a scientist. And through this work, I got the Science Achievement Certificate, which basically meant that the conveners really appreciated the fact that I showed up with spare change glued to a poster board from the bottom of my dad's desk. Today, after 19 continuous years of school, I have a bachelor's and a master's degree and a PhD on the way, but they stopped giving out science certificate achievements. So I don't know if the trade-off was worth it. I work at the Department of Earth and Planetary Sciences at Northwestern University, and I'm advised by Dr. Daniel Horton. And we look into questions that into questions about air quality at the intersection of climate. So what are the processes that make our air quality worse? How do we live and make this environment more livable? And in particular, I get to study the city that we live in. So here is the Chicago skyline, and it's a really nice day. And my question is, how do we go from just your average Tuesday that looks like this into something that looks like this? It's super smoggy, and you can tell that it's just not as pleasant to be outside, and it's going to be more difficult to breathe. But what are the factors that actually get to worsening this air quality? So we know that we have pollutants being emitted into our environment, but in actuality, these are pollutants that you and I are actually very familiar with. We emit pollutants when we're driving our car. So this is a combustion process. When we burn fossil fuels, we create carbon dioxide, which you guys probably know as one of the main perpetrators of climate change. But we also make these pollutants that are hazardous to human health, like nitrogen dioxide, carbon monoxide, and particulate matter. Additionally, we combust fossil fuels whenever we're using electricity. So when you turn on a light, you've got to get that energy from somewhere. And in Illinois, a large portion of our electricity comes from the combustion of coal. And that coal is actually pretty bad for the health of the people who live around this coal power plant. Additionally, we emit pollutants whenever we're using our personal hygiene products. Here I have a picture of soap, but actually whenever you smell something, you are actually smelling these volatile organic compounds. So this is a different class of pollutants, and it's a little bit more nebulous, but they're really important to the pollution that we see in urban environments. And then finally, we also get chemicals from plants. You have smelled a rose before. Whenever you smell these plants, you're actually smelling these volatile organic compounds, similar to the ones that are inside of our personal care products. And so while these plants are great in the city, they actually can emit some pollutants that can be hazardous for human health. And not any of these sources can be particularly bad necessarily, but we can actually, when we combine all these pollutant sources and then add together some weather, so like wind, sunlight, any kind of other weather process like rain, we can actually take a day that looks like the slide that I showed before, and then end up proliferating the pollutants that we have in our atmosphere. So the emission sources might not even change. Just it can be the weather can be in such a way that we can end up growing the amount of pollution that we have shown here. So one of these pollutants that's really important to understand, particularly for the city of Chicago, is ozone, which I have here. Ozone is a secondary pollutant. So primary pollutants are these chemicals that we directly emit. So when you drive your car, you are creating nitrogen dioxide, carbon monoxide, particulate matter. It's pretty straightforward. Secondary pollutants, on the other hand, are not as straightforward. They actually form in the environment from whatever is available there. So for example, ozone, key ingredients include nitrogen dioxide, which we make through the combustion of fossil fuels, and then also volatile organic compounds, which we have in our soaps and through our natural greenery in the city. So when we combine these two emission sources in the presence of sunlight, we actually form ozone, which can be really toxic for human health. And actually in the city of Chicago, we're violating EPA standards for the level of ozone that we have in our city. And while this process is really complicated, atmospheric chemists, people like me, we're pretty sure about how these processes work, and we dedicate a lot of time to study how these emissions and then the meteorology interacts in order to make these pollution episodes. And the reason why we invest all this time and resources in order to understand our atmosphere is because these pollutants end up harming human health. Certain members of our community are also more vulnerable to these pollutants as well. For example, when we look at nitrogen dioxide, ozone, particulate matter, these are all respiratory irritants. So that means that they can trigger asthma, which is a really common respiratory irritant. But longer exposures to higher levels of pollution can also lead to increased health effects or negative health effects like cancer and other things. These pollutants are also can become so small that rather than just irritating the lung tissue, that they can get ingested into our bloodstream and begin to affect our heart health. And they can bring down our platelet levels, and with increased exposure to higher pollution levels, it can lead to things like heart attacks and strokes. And finally, these pollutants also can negatively affect our brain function. Studies have linked exposure to pollutants to an increased risk in Alzheimer's, depression. Basically, all of these pollutants end up affecting our community in a really negative way. And here, for example, is how pollution interacts within our Chicago environment. Here I have a figure on the left that is the rate of asthma hospitalizations of children across Cook County. And what you can see is that on the west and south side of the city of Chicago, we see 3 times the risk of an asthma hospitalization as compared to a baseline exposure level. So there's certainly a really great risk of being exposed to high levels of pollution within the city of Chicago. And given this information, we need to do something about it. In fact, there is legislation in place that does address this problem. We've known that pollution is bad for our health for a very long time, and the legislation that I'm referring to is the Clean Air Act. So the Clean Air Act was established in the 1960s in order to address hazardous pollutant sources. So the Clean Air Act, it regulates things like industrial sources of pollutants, and it even sets vehicle regulations in order to prevent pollutants from becoming at really high health hazardous levels in the environment. So in this figure here, I have the pollutant levels in colors, and then I have gross domestic product in black. And basically what this shows is that over the past 40 years, we've decreased our pollutant levels across the United States while still managing to increase our gross domestic product, meaning that when we regulate pollutants, we're not actually shutting down the environment, we're helping out the health of our community. Specifically, what we see is over the past 30 years, we have prevented 230,000 deaths from these reductions in just particulate matter. We also have avoided 255,000 hospital admissions and ER visits from bringing down these pollutant levels. And it doesn't necessarily even have to mean that we've saved people's lives. We've even just improved people's day-to-day living, as we've saved over 21 million days of work in school for people that would have otherwise been negatively affected by high levels of pollutants. And all of these benefits basically have come at a cost of $65 billion that has benefited our society, our U.S. Population with $2 trillion in benefits. So that means that it's $30 of benefits per $1 invested into the Clean Air Act. So the real reason why that this is such a successful piece of legislation is because over time we have looked back at the Clean Air Act and continued to update this legislation given the newest science. We have gotten a lot better at understanding how these atmospheric particles interact with human health, what levels are acceptable for people in our environment, and then also when technology becomes available, making sure that people actually use it and clean the air and tighten regulations when it is beneficial. So this is what I'm interested in, understanding how we can take the air that we have today and continue to apply this success story, but even at a more localized scale. So the first question that I have to ask is, how do we identify pollutant hotspots? Well, as I was just talking about the Clean Air Act, the EPA, the Environmental Protection Agency, the people in charge of enforcing that piece of legislation, they have a sensor network that specifically looks for the atmospheric constituents that are regulated by the Clean Air Act. Here I have nitrogen dioxide, ozone, and particulate matter sensors across Cook County on the left panel. And what you can see is that we have several sensors across the city given each atmospheric constituent. But to the right, I have put back the rate of asthma hospitalizations across Cook County. And importantly, there are some areas that have high rates of asthma hospitalizations, but no EPA sensors to really see what's happening there. So while we are catching these ozone violations across the city of Chicago. And while we are testing the air around the city, there still are hotspots that are not being monitored given these EPA sensors. So I'm interested in filling in the gap. And in order to do this, I use satellite observations. So taking a step back in time, here is our first complete view of the world's weather. We just got satellites in space, and this mosaic took 24 hours in order to get a picture of the Earth's atmosphere at that point of time. And before that, we didn't really know. We had ideas about what the Earth's surface actually looked like, but this is the first time that we actually were able to launch our own remote sensing tools. And this really started an explosion of new technology so that we could sense our environment in real time. And then that takes us to today, only 60 years later, where we have only 40 years later, we have an entire constellation of satellites, and many of them are dedicated to looking at our weather or our air quality. Here I have NASA's satellites, but I actually use one of the newest satellite tools called Trophome, which is a European Space Agency tool, in order to look at air quality on such a fine scale that we can actually start to sense cities. So it's no longer just pictures of what's happening on the Earth's surface. We're beginning to dissect what's happening within the atmosphere. The atmosphere is 78% nitrogen dioxide, 21% oxygen, and then less than 1% includes all of that carbon dioxide, all of the ozone, all the nitrogen dioxide. And we are now at this point with these technologies where we're able to observe that less than 1% with these remote sensing tools in order to figure out what's happening with air quality in our cities. So here is what the air quality actually looks like. Here is the Trophome instrument, and what this tool does is that it actually circles the entire globe every single day and takes a snapshot of what's happening within the atmosphere. So we can actually use this tool to zoom in on the city of Chicago and see what's happening. And this tool is great because it does fill in the blanks between those sensors, and we can start to use it to identify elevated levels of pollution, but there still are some caveats with respect to this tool. For example, the fact that we only get information once per day. I would prefer it if I could see more information at more times, but this is great as a snapshot for what's happening. Additionally, we're getting information across an entire section of the atmosphere. So we aren't just measuring what's happening at the ground, which is what's most health relevant. But typically when there are elevated levels of pollution in the column, we would expect to see elevated levels on the ground. So it's a little bit more of a correlation as opposed to literally what's happening at the surface, but it's one of the most amazing tools that we have today in order to sense what's happening in real time across the entire world. So just to take a little step back, in order to sense what's happening in real time, I use the sensor network, which is providing us information at points across the city of Chicago, though it isn't really filling in those gaps. And to fill in those gaps, I use satellite data, which is providing us geospatially continuous data, but only once per day. So what is happening between these points of observations? What if I want to know more about what's happening in our environment? Well, that's when I turn to numerical model simulations. So I used chemistry climate models in order to estimate what's happening between those points that we don't really have information on. And the way that we know what's happening is that we take emission sources. So we know where the cars are, how many there are in the city. We know where power plants are. We're always monitoring their pollutant output. We take these emission sources and then we add in what we know about weather. So what a weather forecast might say, I can add that basic chemistry and physics to the emissions and where they are, and begin to actually get an even finer picture of what's happening within the city of Chicago across all space and time. So for example, what this actually looks like as an input to our model, we can look at, for example, nitrogen dioxide emissions. Now, this is something, a byproduct of combustion. Again, so this is where our carbon monoxide, our water vapor, our CO2 is coming from. And as an input to the model in Chicago, it looks like this. So darker colors means that there is a higher level of nitrogen dioxide emission, and lighter color means that there's less. And what you can see is that the highways are really lighting up across the city of Chicago. So for nitrogen dioxide emissions, it's safe to say that most of these emissions in our city are coming from vehicles. And then what we do with these nitrogen dioxide emissions is we add in our weather forecasts. So what happens when you add the wind and the sunlight and the rain and the other meteorological processes, basically this. So what used to be a really orderly picture of just the highways lighting up in dark colors where clearly the nitrogen dioxide was staying, you can see that on an hour-by-hour basis, we have wind moving from east to west, and moving those emissions from just the highways and mixing them around the city so that they get consumed by other chemical species and other atmospheric constituents, maybe get transported to other places. So yeah, this is what our model does. It takes what we know to the best of our abilities, and we begin to get information on an hour-by-hour basis across all points in time. And as a result, we get this really amazing picture. Now, we use these models as our best estimates to what's happening. The circles that I have on this image are actually EPA stations, and they're colored with what level of nitrogen dioxide they find. And we find that our model does really well at estimating what's happening on the ground with respect to what's happening according to the EPA stations. And then we also have those satellite observations, which we can also validate with our model and figure out if we've got our atmosphere estimations right. And for the most part, we do really well. And then we end up getting so much more information than what just our observational network can give us. So we can actually begin to ask all of the questions that, the simple observational network may not be able to give us. We can ask what happens when we change emissions. We can ask what happens just what's different about yesterday versus today in a place that we're not normally monitoring. Here, through this simulation, you can really see the fact that we've got the highways lighting up. We can see power plants, which are always on, giving off their nitrogen dioxide plumes. And then the way that these plumes move across state lines and around our entire Midwest area. And again, how important just vehicles are for this nitrogen dioxide in our environment. So just to reiterate, how do we identify these pollutant hotspots? We use observational tools like satellites and sensors. And then when we don't have enough data, we can start using our best estimates. So we can use chemistry climate models, these numerical model simulations, in order to figure out what's happening in between observations. Okay, now that we know what's happening, where is the pollution anyway? Within the city of Chicago, what are we looking at? Here I have a map of nitrogen dioxide, and this is the average summer concentration that we have across our city. And what you can basically see is that the highways are once again lighting up with the highest concentrations of nitrogen dioxide. This nitrogen dioxide comes from a combustion of fossil fuels. And within the city, nitrogen dioxide mainly comes from vehicles. So it's not surprising that we see these hotspots being really concentrated over the highways. And when you average this meteorology and chemistry, it kind of ends up looking like the emissions that I showed you earlier. It ends up being a little bit more orderly in that the pollution is clearly over the highways, but you can also see the fact that there is some spread, therefore making places like deep inside the loop really a nitrogen dioxide hotspot. We can also look at ozone. So here is the average monthly summer ozone concentration. And what we see here is pretty much the opposite pattern of nitrogen dioxide. And for that, I mean that the lower concentrations of ozone are over the highways, and the higher concentrations of ozone are elsewhere. And this is because ozone is a secondary pollutant. So just once again, nitrogen dioxide and volatile organics in the presence of sunlight can form ozone. But when nitrogen dioxide is at high enough levels, actually this equation goes the other way, and nitrogen dioxide begins to destroy ozone. So that's what we're seeing over these highways. It's a titration effect of nitrogen dioxide with ozone. And for these ozone concentrations, what's really important is that these high levels appear with lots of sunlight, so summertime, we've got it, and high temperatures, again, summertime, we've got it. And this is a really important pollutant for the city of Chicago because we are violating the ozone standards according to the EPA. And this question of what to do with ozone is obviously really complicated. It's not just about any kind of combustion processes, even though that's clearly an important input. And it's not just about like these volatile organic compound sources. We need to look at this in kind of like a holistic manner. So to answer the second question about where the pollution is pooling, we can see that nitrogen dioxide is elevated over highways and ozone is elevated wherever nitrogen dioxide is not. Now on to the third question. What can we do with these maps? We've gotten these really high resolution maps of air quality across the city. Now, what do you want to do with them? First thing that my lab group does is we consider policy changes. Since we do have this amazing tool of the chemistry climate model, we can actually start to test out different scenarios given what we know about our environment today. So, for example, we have from the news that the city of Chicago approves the transition to 100% renewable energy with the CTA. So basically, as a climate change initiative, the city of Chicago is targeting greenhouse gas emissions. And that's great. A decrease in carbon dioxide is, really important when we're considering climate change. But there is a side effect that when we're targeting greenhouse gas emissions, we're also going to change the air quality because this combustion, the combustion of fossil fuels, which is what drives our cars, also forms these air quality pollutants like nitrogen dioxide, carbon monoxide, as I said before. So my question is, what happens to air quality? And with our lab group, we actually have set up some experiments in which we've asked ourselves the scenario, what if we model the electrification of all municipal vehicles? So for this, we have basically made the assumption that, okay, so now these vehicles run on batteries. So we're going to zero out their combustion from the tailpipe because now all of their energy is coming from electricity. So we can put that electricity to the power plants, and then actually in order to model all of this municipal vehicle electrification, we're only using about 1% of Chicago's energy. So we're actually kind of changing the power demand to these power plants in a minor way. So we actually don't really change the power plant emissions. So in this scenario, we just zero out what's happening with municipal vehicles, meaning the refuse trucks, the the transit buses and then also the school buses as well. And when we are isolating these tailpipe emissions, in particular with the combustion emissions and the stuff that makes nitrogen dioxide, and everything that I've told you about the relationship with nitrogen dioxide and ozone, what do you think ends up happening with ozone? Well, nitrogen dioxide decreases, but we also see an increase in ozone. Both of these changes are pretty small, but this is an important effect that actually has been observed over and over again, so much so that we have a name for it, and it's called the weekend effect. We actually do see a change in behavior naturally across the city over the weekends, in that when people stop driving down to the loop for work, on the weekends, we do see a resulting increase in ozone. This is because of this titration effect with nitrogen dioxide and ozone. So while this isn't like the best outcome, this is actually very expected from an atmospheric chemistry standpoint. So we can just press this policy further by asking the questions: what if we electrified other vehicles? In that, when we change this policy, can we get it to a point where the entire air quality of the city gets better? Like, what other vehicle mixes can we put into this policy in order to just get a slam dunk on air quality? That requires, tinkering to find which chemical state is necessary to better air quality. And while these questions are great, I actually don't have the answer for them. We are actively investigating this in our lab, but I think that overall this is a great policy, in particular for decreasing carbon dioxide emissions. Just atmospheric chemistry makes things a little bit more complicated. So we get this decrease in nitrogen dioxide, but we also see a resulting increase in ozone. And then just to pivot a little bit, I just talked about the way that we can modify policy and then test them out using these chemistry climate models. But we can also basically look at health questions as well with this model. Given this hypothetical scenario, we see a change in nitrogen dioxide and ozone. We can quantify that on like a health level through a health lens and figure out how that policy might change. In fact, I would argue that we are living in a reality today in which we are an experiment, where we were supposed to be living in a way that had our emissions going one way, and then COVID happened. And now I'd say that we're living in a way that has drastically modified both our emissions and our health. And this is another question that's being actively investigated within my community of atmospheric scientists. So the question, what is the link between COVID and air quality, has several points to it, in that we have seen a change in emissions, particularly carbon emissions, across various sectors in our economy. So we've seen a change in industry and power. So this kind of like combustion, these kind of combustion processes have changed given our behaviors of staying at home, being under lockdown scenarios, maybe not completely using our entire economy. And then we've also seen changes in road transport, which has actually been one of the greatest changes from COVID. And you can imagine, while we have decreased our carbon emissions, there's another question about what has happened to air quality. Carbon emissions, they're global. This air quality change is highly localized and very dependent on meteorology. Because, as I said in the beginning of the talk, we have air quality emissions, but just changing these emissions doesn't necessarily mean that we're going to change the pollutant concentrations in the environment, because it heavily depends on meteorology. And that's what this study actually has shown. In green, we've got a model of what reality was supposed to be like without these COVID shutdowns. And then in blue, we have the Trophome satellite observations of air quality across the cities of Chicago, New York City, and Los Angeles. And interestingly, what you can see here is that Chicago, at the beginning of the shutdowns, so around March 17th, we actually, onward to April, we actually don't see that much of a change in nitrogen dioxide density. There's a 3.5% drop between what the hypothetical given the weather that we experienced, given the emissions that we were undergoing, that we should have been undergoing, we see only a 3.5% drop. And that's because in this early spring time period, we weren't in a pollution season. In Chicago, we weren't really in a place where we had all of that sunlight in order to really make the chemistry go and the heat. So we actually didn't see that much change in air quality at the beginning of this shutdown. But other places like New York City, I think their lockdowns were a little bit more stringent. So you actually see a greater drop. And then for Los Angeles, which I think of as just a very vehicle reliant city, once they went into lockdown, they saw an even greater drop in air quality. Or in nitrogen dioxide, given these shutdown procedures. So while the carbon emissions have all gone down in a global sense, what the change in what air quality has shown in this change in air quality, it's been a more localized effect because of the meteorology. So not all places have changed their background air quality in the same way. Additionally, we can look at COVID just knowing that it's a respiratory disease and it attacks various parts of our health system in a very similar way that air pollution does. So people have asked this question by saying, what's the link between the exposure to air pollution and to health outcomes, which several studies have tried to quantify what was happening between this. And here on the right, I have a picture of the average particulate matter concentrations across the United States. And then on the bottom, it's the COVID-19 deaths before, I think before July. And basically you can kind of tell that where there's higher PM 2.5 concentrations, there are greater amount of COVID-19 deaths. So there is some links basically that say that if you are in a more polluted environment, you're more likely to have a really fatal outcome when getting COVID-19. But this is a very open and active area of research. This is certainly not concluded, and we're still continuing to get data about what's happening with respect to this current pandemic and then its relation to the environment that we really live in. Actually, there was a study that my lab group and this research that I've spoken to you about was a part of, and we looked at the connection between air pollution exposure and health outcomes in Chicago specifically. So on the left, I have the death rate by census tracts across the city of Chicago. And then on the right, I have, once again, the nitrogen dioxide concentrations across the city of Chicago. And we, with our collaborators, basically tested out the various links to what could possibly be contributing to COVID-19 fatalities in the beginning of this pandemic, given like the average exposure of concentrations of pollutants with these maps that I have shown you. And what we found was that social factors were more linked to fatality than air quality exposure. So we saw like basically the ability to social distance was far more important than far more correlated with COVID-19 fatalities than the actual average pollutant exposure in the city. So basically the access to internet and these things that basically allow us to work from home and follow social distancing guidelines were far more important in determining COVID-19 fatalities at the beginning of this pandemic. But again, this is a really open and active area of research. We still have to get more data about really what's happening with respect to COVID and air quality. But this is just one of the examples that we had these high resolution air quality maps, and we managed to ask a really relevant health question with respect to what's happening today. So, as my final thoughts, just to summarize what we have spoken about over the past 40 minutes, we've looked at air quality with sensors, satellites, and simulations, and then we have figured out where the pollution is pooling in the city of Chicago. And with these pollution maps, we can really identify what's causing the pollution. And once we figure out what's causing the pollution, we can test policies that address these pollution events with that can clean the air. And basically, we do have the science to change air quality for the better. We know where the pollution is. We can test out what we can do about it. We just need to make sure that we continue to pursue it. And with respect to the Clean Air Act and everything that we've done, we're really good at answering this question about what we can do to clean the air. We just need to continue to invest resources into this problem. And I'm sure that we'll continue to do that moving forward. So thank you to my advisor, Dr. Daniel Horton, Dr. Jordan Schnell with helping me with the modeling that I have here, and Amy Rogan for some data analysis that she helped out with this science project, as well as LADCO, ESA, EPA for the data, and the National Science Foundation for funding. And I can open the floor for questions now. Thank you.
Thank you so much, Anastasia, for sharing your research. That was really great. I thought, personally, the GIFs were amazing, just how detailed they could be in terms of what you can actually get in terms of images for where the pollution's actually going on a really small scale. I thought that was awesome. So before we get to the questions, I did just want to apologize to those of you who wanted to watch on YouTube. We apologize for the technical difficulties on our end, but it looks like a lot of people were still able to switch over to Facebook and ask their questions there. So thank you for understanding. Our first question is, do you think that the Clean Air Act is enough to regulate pollutants within Cook County, or is there more that we need to be
I
doing?
believe from these high resolution simulations that I was showing, we have this question about air quality is super localized. So while the Clean Air Act specifically looks to regulate, the background ambient pollution and like our average exposure as a whole, I believe that we perhaps like as the city of Chicago can do more in order to identify and mitigate localized hotspots. This is a far more local issue than maybe some federal legislation can really work on. So I think we can do more, but it might need to be done on our own initiative.
Yeah. And to piggyback off that, I guess, are there any policies that are in place within either the state or city government that you know of that are kind of aiming to tackle it at a
Off the
smaller
top of my
scale?
head, I can't think of any particular air quality initiatives, but I certainly think that we will begin to see changes in air quality as we pursue these climate change initiatives. For example, I showed the bus electrification. I think in general, that's a great policy, even with respect to air quality, in that like idling buses aren't good for air quality, particularly for people who are sitting at the bus station. So even just removing that pollutant source from people who are just waiting for the bus, that'll be huge for people at bus stops. So I think there are like even higher localized benefits to these kind of policies that I haven't been able to capture with my model because we run it at a 1 kilometer squared scale. So I can't think of any air quality initiatives specifically, but I think that we definitely have some routes in our local government in order to, seriously pursue these initiatives.
Yeah, I think that's great. And even being able to see something at, a scale as small as 1 kilometer is really, really small in terms of the grand scheme, even of the city of Chicago. So this next question is a little bit long, but someone's asking if the NO2 emissions from highways/vehicles take into account the documented disabling of emissions controls, and cites that The US EPA just documented tampering in diesel pickup trucks and suggested some bigger trucks are also disabling these NO2 controls.
Yeah, so
Um,
I do not think that these emissions inventories are necessarily able to capture these kinds of out of compliance vehicles, mainly because they might be less common than just like overarching. Most of the vehicles will be following the rules. And because this is such a complicated problem, unfortunately, the model will not specifically capture each and every single vehicle. It kind of takes the average exposure of the average emissions of each of these trucks. So there definitely can be unidentified pollutant sources, emission sources, and things like satellites and other sensors can actually begin to identify those things. So that's why we also have our observational network, and it's a really important part of this equation because we have these models and we're always running them. And if the sensors are always higher than what the model is showing, that's an indication that there might be something that is out of whack in our emissions inventory. And we have a lot of people working on those questions and then making sure that vehicles and other things are in compliance with that. But unfortunately, in my model specifically, in my study, I am not looking at that specific question.
yeah, I'm sure there's a lot of variables that you're constantly adjusting for on really fine scales to make sure the model is as accurate as possible. But again, if it's undocumented, that's pretty hard to
Yeah,
hard to
I use
examine, I would
what
think.
I can get information on.
Yeah, that makes sense. Are the texts that you're using to paint a picture of air quality at a local scale in Chicago being used in other cities right now?
Sorry, could you repeat the question?
Yeah, no problem. Are the texts that you're using to paint a picture of air quality in Chicago being used across other cities right now?
Yes. So I would say a lot of cities and perhaps a lot of scientists, rather, I would say, do use this kind of approach in order to look at air quality. Maybe not everyone uses all three data sets, but there are highly specialized scientists in each of these fields as far as sensors go. Like I'm using EPA sensors, but there are people who are using these low-cost sensors and getting even more information at a higher resolution across different cities. But with respect to like what the cities are doing, they might not, use these highly localized maps because they're so specific for what I want to research personally. But I believe that scientists like me who are interested in figuring out the connection between the meteorology and the urban environment, we give this data to like our local government whenever we come up with this, because obviously we're working in this environment. We want to make sure that we can give whatever information we can in order to better the pollution, for example. And we have invested all these resources to test out these plans. But yeah, so I'd say it's more of like if a city has scientists who are interested in this question, they're working with the scientists in order to address these questions, as opposed to specifically, there might not be an air quality modeler at the local city office, but there might be one at the local university. So it's those kind of partnerships that ask these questions and apply these techniques.
Awesome. Thank you. And a question that goes well along with, I think, the way you ended that last one. Is there a lot of international collaboration in climate change studies that happens?
Oh, certainly. Yeah. With respect to climate change, since this is such a global problem and so many, like, there's so many variable factors, this is certainly something that is asked by scientists across the entire globe. It's why we have like satellites that observe the entire globe. We do have satellites, that are geostationary and just look at one area, but we also have these satellites that are international cooperating developments in order to figure out what's happening all across the entire world. And scientists get together and discuss what they can do on a global scale, even when it is like initiatives that are so localized. Because even, what happens with respect to Chicago's carbon emissions once they, completely electrify the municipal, like the transit fleet here. That is something that maybe a different city across the world, even in the United States, what they'd want to know and how successful it was. This is a huge international collaborative uh, effort that's happening.
Yeah, it seems like, anytime we hear about climate change and environmental change as issues, it's really great to see that there are so many international collaborations that are all working to tackle that problem together. Hopefully that gives us a better chance to fight some of these things.
Yeah, like I'm using a European tool in order to do research over the city of Chicago.
Yeah, that's right. You did mention that. Someone's wondering, are cities with cloudy climates like Seattle safer for air quality than places like Chicago?
Actually, I have been talking about, the city of Chicago, and we have some very specific climatology that's conducive towards, like, for example, ozone and NOx pollution, because these are photochemicals. But places that experience a lot of cloud cover might experience different kinds of pollution episodes. So I would think, like in Seattle, what would be far more important might not be the photochemicals, but perhaps things like particulate matter. So particulate matter is it's not a photochemical. It's directly emitted a lot of times, and it can actually get accumulated in the atmosphere given a certain kind of atmospheric event. We actually see it in the wintertime in the city of Chicago. We have elevated levels of particulate matter. So I think places like Seattle, they just live in a different meteorological condition that can still be conducive to air pollution episodes. It just might not be the same mechanism as what we see in the city of Chicago.
That makes sense. Some more research needed on that front.
Yeah.
So someone is taking a stat. They commented, it's a great takeaway stat that $1 spent on the Clean Air Act results in a $30 benefit. And then a more philosophical question off of that. Why do you feel there is still so much pushback to reducing climate change inputs if that stat exists?
Yeah, I think it's because that these kind of benefits, these kind of health benefits, are still kind of like nebulous to a lot of people. You don't really think about like one day you're having more of a struggle breathing than the next day, but these are things that are felt in the macro kind of sense. So I think that we need to continue to highlight the fact that these benefits are real and that they exist. The fact that, like when we invest into these initiatives, we actually get a return. Like we see these pollutants decreasing because we continuously regulate and legislate and continue to pursue these initiatives. So I don't know why anyone would ever push back on climate change initiatives. They're super great with respect to our health and also our, resilience as just humans. So I think that continuing to highlight these stats, and maybe people just don't know that it's a really good investment for these environmental policies. But yeah, I've made a career out of this. I don't know why people wouldn't.
Yeah, I think it's a tough question to answer, right? And climate change, especially if you talk about air quality, is something that is really hard for people to visualize. And so I think, I already brought up the gifts, but I'm obviously a big fan. And I think, seeing them in a more tangible way does make it easier for people to understand. And obviously attending talks like the one you gave today makes it easier for people to understand too. Yeah, so that's actually all of our questions. So we'd like to thank you, Anastasia, for speaking with us today on your work. I think it was really great. And I think what a great way to learn about, our own city and the air quality that we have here in Chicago, and some of the initiatives that, are in place to make it better and what we still need to work on as a city. And everyone else, thank you for tuning into today's program. Again, we apologize for the issues we had streaming to YouTube today, but hopefully you were able to still watch our video on Facebook Live. Otherwise, all of our videos are recorded and we do upload them to YouTube and Facebook. So you can watch them later. If you missed something while you were waiting for things to start on YouTube, you can just rewatch it at a little bit later time. If you'd like to evaluate our program today, please go to C2ST to www.cnf.io to evaluate our program. We'd love your feedback in order to continue to offer relevant programs like this that highlight some really important research being done both in Chicago and sometimes on a broader scale. If you enjoyed the program, please consider donating to C2ST at c2st.org, where you can also find archives of our previous programs and our timely STEM blogs. If you're interested in climate change, you're more than welcome to search for other programs related to it there. Thank you again for watching. We hope to see you guys at our program soon.